Thanks. So you guys ready to get started?
Yep.
Yeah.
Sorry, I'm zoning out. I'm exhausted. We'll keep it moving. All right. So lesson 5, part 2. Or number 6, right?
Yeah.
The mean score of all GRE scores is 150.8 with a standard deviation of 8.8. A. Scores on the quantitative portion of the GRE are approximately normally distributed with mean equal to blank and standard deviation equal to blank.
Did you spell it in? Isn't it 150.8?
Yeah, so it's just, what I was
Okay.
thinking was just the numbers that they already gave you.
I think it's just supposed to make it easier for like the overall equation to plug everything into.
Gotcha. So we know what
Like what we're working.
Where to plug things in.
Okay. It's like, all right, so we also have 8.8. Okay. B. What proportion of the people who take the quantitation portion of the GRE will score above 165? So we can use that little graph table, right? The text if we figure out the z-score.
The applet thing.
The applet, yeah. How do we get the z-score? Give me a second to think.
It's the number minus
So z
the-
equals x minus
the mean divided by the standard deviation.
And
yes.
that
I got 1.613.
So it's 165 minus 150.8 over 8.8, right?
Yeah, and so what did you get?
I got 1.613.
Yeah, that's what I got.
yeah, me too.
And then what do you get when you put it in the probability?
1.613, huh? 0.0534.
Okay, how did you get that? Because I keep getting 0.067 in the area. This has been my biggest hang up with this system.
So do you have blue selected on both sides?
Yes.
So you select the left side and just keep it on the right because we want everyone that's above 165. And so it's when we look at the z-score, it's got the negative z-score, so it's also including anything that's that many standard deviations away on the bottom end as well.
Okay, I didn't realize you could deselect that.
When you do that,
because as I've been doing this whole assignment, I'm like, she put in the wrong values for her own assignment.
going crazy. Yeah. No.
I didn't download. I haven't gotten into the applet yet. I've been having some technical difficulties, and so doing it on paper, it says so you're supposed to multiply the probability by the z-score, which is greater than whatever the mean was, right? That makes sense. Or should I just really figure out the? I might have to go tech support about the applet.
You should be able to access it on lesson 5, like the reading on the wiki. It's like a third to almost halfway down the page. Maybe
Is
two-fifths
it
of the way down
for
the page.
textbook reading or is it something else?
Lesson 5, normal distributions, BYUI statistics text. The page.
Okay. So I'm in there. Do you know what point it is?
2.1.
Oh.
So for the area that you plug in, are you just supposed to type in the mean?
So so you got to figure out the z-score. And you enter the z-score down on the right. And so I entered 1.613 because that's what we had, right?
Yeah.
And so that, when you press enter, and then you make sure you only select the blue on the right-hand side, that gives you the area up top, which is 0.0534.
I'm going to try it again. I haven't had very much luck with it doing anything.
Yeah.
Okay, we can keep going. I'll figure it out.
Okay. C, if a student scores in the 10th percentile, what would their corresponding z-score be? So you type in 0.1 in the area, bam, select the right, and the z-score is 1.282. This is using the applet.
Okay,
Okay,
so walk me through it one more time. So for C, if a student score is in the 10th percentile, what should their corresponding score be?
So you
What did you put in where?
So make sure you only have the blue selected. Wait, let me see actually.
You can like click on anything to make it blue.
Okay, so just select the top end because we're doing the 10th percentile, right? That's
Yeah.
the top 10%.
Oh, so you can even move the red part.
Yeah.
That is super confusing. So
And
I just
you
have
only-
to put C score in one area then, and it computes it in both areas. And then I click on.
Hey Matt, how do you know which site to click on?
1 second. If you just select all of them and you type in 0.1 and hit enter, it won't let you. You select the box. I mean, the z-score will be the same essentially either way. It'll just either be positive or negative.
Right.
Positive z-score is going to be 1.282.
So
Because
you
the
just typed it in what the area was then at the top.
Yes, so 10% is going to be 0.1 in the area field. So you
Okay.
type that in, and then it generates the z-score for us. Since we know what the area is, we can use it to our advantage.
So then what did you get for your, what was it? Did you get 1.645?
For for C of 6?
I think the one that talks about the percentile.
I got 1.22.
Yeah, that's what I got, was 1.282.
Wait, you said you put in 0.1 for the area?
Yep.
Yeah, it's one of
Yeah,
the top
that's
10 percentile.
And it comes out to 1.282, is that right?
I think so.
That's what I got.
That's the best I got. We'll see. This one is going to kick our trash, I think.
Yeah, I think so.
Hmm.
Because then you just have like that one blue section filled in that's at the top end of the cell graph, right?
I think so. I mean, 10th percentile,
It doesn't matter what you click on, actually, it doesn't change.
yeah, it's either 1.282 or negative 1.282.
Cool.
So what does it mean by the quantitative GRE score for a student who scored 10%?
Oh, I got it. Okay. Okay.
So
So does that? Hold on, let me look at the cheat sheet.
This one has the equation, as I was looking through the reading, it's x, so we're trying to figure out what x is. What I think is what we're trying to do. So
and
this
for
is
C they got the negative.
Yeah.
So I guess the 10th percentile would be the lowest 10%, not the highest 10%.
Yeah, that
I
sounds
think
right.
we got that mixed up. 10th percentile is that first 10%, not the top 10%.
1.282.
Yeah, it's negative 1.2816 technically, but I guess you would round that.
Oh, because I think that's what I got the first time I did it, and then I had to change it.
And I guess if there's an E. No, never mind. And so for hang on. Yeah, so it's definitely negative. And then for the next section it talks about
Sorry, I'm still looking at that page.
it gives like the equation. So I just don't know which one represents.
How do we figure out the quantitative GRE score? I have no idea.
Well,
okay, which one are we on? I lost the connection because there's a storm coming through here. So I had to reconnect. Can you guys hear me?
Yeah, I can
Yeah.
hear you. Sorry.
Okay. Which one are we on? I lost the connection.
Oh.
60. We didn't get very far.
Okay, perfect.
So I don't really know how you would generally solve for it. I just see the equation on the cheat sheet. And that we're supposed to solve for x.
Let me take a look at that too.
So normally, like,
Okay. Interesting how they did that.
yeah.
So
And
you've got z equals x minus the mean over the standard deviation. So in order to get the x, you do x equals z plus the mean over the standard deviation, right?
yeah, so x equals the mean plus the z-score times the standard deviation. Is that what you said? So we got the mean.
So the mean is 150.8,
Mhm.
and then the standard deviation is 8.8. Now that we know what the z is, which is negative 1.282 or negative 1.2 0.2816. So
Yeah, good call not rounding it quite yet. Then we just have to do the math, right?
yeah, so about 140. Okay. What's that one?
I think I was getting confused that I didn't read in there that the GRE had to do with, like, what that in particular question was about, because I thought it was a term, and I was like, I wish that they had given us a GRE one earlier in the homework.
I kept looking for quantitative, but I mean, I guess it doesn't matter. Yeah, that threw me off. All the wording threw me off.
Quantitative, yeah, I think it just
Too
seems
many
weird.
abbreviations going on.
Letters, yeah.
Do we kind of understand now what was going on?
Yeah,
Yeah.
I'm following now.
Yeah. We're
Okay.
moving, hopefully.
All right. 7. The mean speed of a hydrogen at room temperature is 1,800 meters per second with a standard deviation of 600 meters per second. So, A, mean, 100. Standard deviation, 600. So we look at B. What is the probability that a randomly selected particle has a speed over 2,500 ms? So Z equals 2,500 minus 1,800 over 600. So we do the math to get the Z.
I got 1.166.
Yeah, me too.
It says 1.1666667, whatever.
Yep.
Yeah.
Okay, so we take that over to whatchamacallit, probability applet.
Okay, and that's the z-score. Oh, well, yeah, so we put that in where the z-score is. This
I
whole
think
thing,
the z-score thing confuses me because it's like the probability that a randomly selected particle has. Like I don't even realize when I'm reading that they wanted the z-score. Does that make sense?
yeah, because it doesn't say z-score. It talks about probability, so then you're thinking probability.
Exactly. So
Yeah. No, I know. The first time it threw me off, but yeah.
So with the z-score, then we take a look at the probability in the area, so 0.1216.
Yeah, that's what I got.
Yep. Is that what everyone else got for B?
So nice, but getting the correct answers now, and not the wrong ones.
So wait,
Yeah.
what were you just saying about B?
So to get B, we figured out the z-score. Then once you enter that into the applet, it allows you to see the area, which turned out to be 0.1216.
See, for my area, I got 0.0478. What did I do wrong? So my z-score was 1.667, right?
1.16667.
1.
Because you have 700 over 600, which is 1.1667.
That's better Okay. Right. I just got everyone down,
What did you
but
guys get for your area again?
0.121.
Area is,
That's the probability.
yeah, I got that.
The probability that it wouldn't is going to be 0.88784, right? we're just doing the math, but I mean, if we're not.
Yeah, it would just still be 1 minus, right? So.
Yep.
So let me just confirm that I did it right. So B, the area was 0.1216, and then the opposite for C would be 0.8784. Right?
0.8784 for C. Yeah.
Yeah.
How did
Okay.
I'm following.
No, you're good. You're good. Is everyone good with A, B, and C?
no? How did you get C?
So C, it's asking for those that are less than 2,500. Because B, we had greater than 2,500. So to get less than 2,500, you take the total, which is 1, minus what we found for B. So 1 minus 0.1216, which gives us 0.8784.
Okay.
Does that make sense?
Yeah. Okay.
For D, they want us to do what we did for B again, only for 1,500. So
So we just plug that back in.
1,500 minus 1,800 over 600. So negative 300 over 6, negative 0.5.
Yeah, that's what I got.
So that, plugging it into the applet, gives us 0.3085. Did anyone else get anything different?
I'm still plugging everything in. You guys are much faster than I am.
That's okay. If I'm wrong, because since I'm going faster, I'll probably be wrong occasionally. So.
Okay, so the z-score was negative 0.5, right? And we're trying to figure out speed that is less than 1,500. So the area would be 0.3085.
Yep. That would be correct.
That's correct.
Well, Ashlyn, are you still with us?
Yes. Yes. Me and this apple are having fighting problems, but we're fine. I get it. I'm just a little.
Wait.
Do you guys, are you guys ready to go on to E?
Yes.
Yeah, I'm ready.
What is the probability that a randomly selected particle has a speed that is between 1,500 and 2,500 meters per second? So to go in between those two to figure that out, we take the answer from D and the answer from B, and we add those two together. Then we take 1 minus the sum of B and E.
So 0.1216 plus 0.3085 minus 1.
So 0.5699. Is that what you guys got?
Did you say taking the answers from B and D or C and D?
B and E, B and D. Yep. So we're trying to figure out what's between 1,500 and 2,500, which means we have to exclude anything below 1,500 and anything above 2,500.
Couldn't you, I think.
Does that make sense?
Yeah, so I got 0.5699.
Yeah.
Right?
Sorry, what did you guys get?
0.5699. Is that what you got, Matt?
Yeah, that's what I got. Give me 1 sec. Sorry. 0.121. I accidentally deleted it off my thing. Plus 0.3085 equals minus 1. 0.5699. Yep.
Okay.
And for the last one, they want to figure out the third quartile for F. Of hydrogen at room temperature. Third quartile. So to get our information, our area is 0.75. So if we go to the applet and select the center and the back and the bottom, 0.75, it gives us a z-score of 0.674.
Well, when I put the area of 75, what's the z-score that we're putting in?
It gives you this z-score that we have 0.75. So it'll give us a 0.674 is what it should be giving you.
I'm getting a 1.15. So I put in the area as 0.75. Do I have to give it a t-score first? Or z-score first?
No, I just typed in the area and it came up with the z-score.
So did you? Which is selected as blue for you?
The middle? Oh no. Okay, well maybe that's it then. Yeah, the middle is 75 or.
So the middle, and so the middle section and the bottom section.
That makes sense. Okay.
There you go. And so when you add those together and you do the 0.75, it should give you 0.674. Is that what everyone else got?
Yeah, that's what I got.
Yeah, thank you so much. That makes so much more sense now.
Good. So then you plug it into the equation. Z equals x minus the mean over standard deviation. So you got 0.674 equals x minus 1800 over 600. And then you just work it out to get x, and that should give us our answer. So we take 600 minus 0.674 equals plus 100. X equals 22. Now let me know when you guys got it.
Okay, I got it.
I got 2,204.4.
Yeah,
Yep.
that's what I got.
Nice. All right.
Yeah.
2,204.4. All right. Is everyone good on that?
Yes.
Yeah, you did great, Matt.
I know, Matt, you're rocking it tonight, seriously.
Thanks. I think my desire to sleep is what's driving it.
Oh, yeah, that's probably it.
Actually, I gotta go finish my English up before midnight, so I don't think there's any sleep. I mean, we'll see. Well, let's see. We want to do like the QQ plots.
Yeah,
I
I guess.
Those are normal. I guess normal is CDF. I mean, it's the diagonal 45-degree angle that we're looking for, right? Essentially.
Yeah. That one or I would think even D is somewhat normal.
Yeah.
Because it's like a steady, or it's like a somewhat steady increase.
So D and F, are we going to think about C and E or no?
I don't know. Oh, C and E. Yeah, I don't know.
I mean, they kind of do a little S thingy. Maybe not.
Yeah,
Yeah, I think that C could be. It has
Not enough
some,
data.
but it's definitely coming along.
yeah,
Kind of goes along where a line would be.
yeah.
Right.
And the data.
I would think so. I think it's
Size
pretty
is small. That's
normal.
what's screwing us. For that one. Okay.
Okay, so are we taking this quiz?
Give it a shot. You guys feel ready?
Hang on.
Kind
We
of
said B wasn't normal, right?
We said D or B.
B as in boy wasn't
Yeah,
normal.
we said it wasn't normal.
Yeah,
And
because it's got that J up.
E wasn't normal either, right? Or E was.
I would say, I mean, it kind of does like an S there.
It says that
Degrees.
plot E is not normal.
And it kind of fades out at the end. It's not
Right. There's too much information that's on one side of the line, then?
Yeah. It says that, so on like the answer key, it says that the downward curve suggests the data is skewed to the right. So that kind of makes sense because there's like a big cluster there and it's all like super close together. And then the rest of it's kind of spread out.
Oh, I'm kind of nervous, but I think I'm ready. How about you guys?
Yeah, kind of the same.
Okay, so we're doing it then?
Or
Yep.
Okay.
So we're going to Group 5 meeting quiz, or Group meeting Lesson 5 quiz. That's all right, let's start her up. Let's hope there's not 30 questions. 16.
Yeah.
Could have been worse.
It's very wordy. Hopefully that's not a lot of problems.
Well, first few are just like true and false and an answer.
Yeah.
So true and true for the first one. Woohoo!
Yay.
For 3, the total area under a density curve must equal 1.
1.
One.
Yeah.
200.
Under certain circumstances, a density curve can drop below the x-axis.
False.
I believe that's possible. False. You can't have negative people in a survey.
No.
Weird. A normal density curve is symmetric. That's true.
True. That'd be built.
Yeah. Get those in the reading.
Use the following image to answer questions 6 and 7. Which of the following elements of the figure represents the z-score in this image? That would be C.
See.
Which of the following elements in the figure represents the probability that the random variable z will be greater than 1.0?
Oh, whoops.
Wait a second.
Well, I
They
think talk about
use z to confuse us, don't they? I feel like they use z to confuse us. I don't know.
which of the following elements in the figure represents the probability?
Probability that the random variable z.
Well, aren't they just talking about what section of the graph would be larger than the?
One.
So when we
Yeah.
talk about
So
the-
is it B?
B. Yeah.
because it's divvied up kind of perfectly right there with the area that the B section is greater than 1, which is that
Yeah.
z-score.
Yeah. I think, because they just word it really weird, because they say random variable, and instead of saying the probability of something being greater than when the z-score is equal to 1.0.
Yeah.
Because they say random variable z. I don't know of that being a term.
Yeah, because I was thinking like z as in the z-score, but maybe it's just.
It's either B or none.
I would think B. Like B makes sense to me.
Yeah,
That's what
I follow B.
Mr. Canelli, we're complaining. No, just kidding. All right, yeah, let's just do B. What the heck? According to the 68, 95, 99, 7 rule, What proportion of the data from a bell-shaped distribution will be within one standard deviation of the mean?
68.
68. Correct.
Do we need to put? Oh yeah, it's already in percent.
It's already there on that.
Yeah.
Suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -1 and 1? Give your answer as a decimal. Accurate to 3 decimal places. If the answer was 0.389184, you would enter 0.389. Okay. Proportion of
I'm a little bit confused on, like, so we're just putting the z-cores as -1 and 1?
I think so. So what's in between that? 0.6827, right? Or 0.683?
0.63, yeah.
0.6, yeah.
0.683. 10. Suppose random variable z has a standard normal distribution. Use your normal applet to answer this question. What proportion of the values from this random variable will be between -2 and 2? Could be some variation of 0.95.
Yeah.
0.9505.
0.95.
955.
Yep. Because they're being tricksy with us. (0.955). 11. Suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from a random variable will be between -3 and 3? All right.
0.997.
Yeah.
Yeah, that's what I got.
197. Yep. Um, 12. Look carefully at your answers to the last 3 questions. What do you observe?
Wow, it kind of sticks with that 68, 95.
95, 97.
Yeah.
Yep, follows that rule. Hooray.
This next one looks like fun.
Yeah.
Oh, wow.
Protein that is concerned.
All right. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body weight. The population mean protein requirements for adults is 0.66 grams of protein per kilogram, or times kilogram times, or per day. Okay, per kilogram per day. Okay.
Oh my gosh, I just got kicked out of the quiz. Does it let you, like, get back into it?
Yeah, I think if they kick you off or like your computer dies or something, then it like just saves it and then you just go back on and it will say like continue.
I just had, like, a mini heart attack.
No, that's happened before. To me, yeah.
Oh, thank goodness. Sorry, I'm so sorry I interrupted you, Matt. Keep going.
Okay. Are you ready?
Yeah, I'm totally there.
Okay. Information to answer questions 14 through 17. There's no 17. Interesting. Okay. What proportion of the population have a protein requirement that is less than 0.6 grams of protein per kilogram per day? Your answer is a decimal. Population mean is 0.66. Okay, let me do this. So, mean equals 0.66. Standard deviation
It is
is 0.07. And x equals 0.6. So Z equals 0.60 minus 0.66 over 0.07.
So, do you guys get negative 0.8571?
I got negative 0.8571. Yep.
Okay, that's what I got.
What did you get?
Negative 0.8571.
Yeah, that's what I got.
Okay, yeah.
That equals the Z. So we punch that in, correct?
0.8571.
Into the app.
Oh, I have to put it in the app, huh?
Yeah.
Ugh.
And we're looking at that anything that and less, right?
Yeah.
We're at 0.1957.
You said 0.1957? That's what I got.
1957.
Yeah, 1957.
And it wants it to 3 decimal places, so 0.196.
Six.
And that's 13?
Yeah.
Wait, that's 13?
Yes.
0.196.
So if we take 0.196, we do 1 minus 0.196. There's 14. So what proportion of the population has a protein requirement that is more than 0.6, rounded to 3? So 1 minus 0.196 equals 0.804.
Yeah, you can also go to the applet and you can just do in the things, but I just wanted to make sure. So that one worked. So it was 0.804. Nice.
Okay, so 15. What proportion of the population have a protein requirement that is less than 0.7? And we do what we did for 13 again, but with 0.7. So 0.70 minus 0.66 over 0.07 equals 0.7 minus 0.66 equals divided by 0.07 equals G is, I got 0.5714.
Yeah, that's what I got.
57.
0.5714.
Yeah.
And we want that is less than that.
Yeah.
Which is 0.716.
Yes.
Yeah, that's what I got.
Wait, what? 0.71. Wait, what did you guys get?
0.716.
So the Z-score was 0.5714.
Mm-hmm.
And so with the middle section and last section highlighted, the area should be 0.716.
Okay, got it. That makes sense. Just kidding. Yeah, okay.
All right. You guys left at 16, guys. Woo! 16. Define the area between the two values. You can subtract the area to the left of each of them. Make sure the answer is positive. This is the probability that the random selected observation will lie between the two values, and this is 0.6 and 0.7. So we take what? If anything left of 0.7 is 0.716, and anything left of 0.6 is 0.196. So to get the in-between, we take 0.716 minus 0.196, right?
Yeah.
Wait, what was the first value?
0.716, anything left of 0.7. Because we want between 0.6 and 0.7.
Isn't there like a way to use the applet to answer the question? Is that wrong?
No, but I don't know how you would.
I got 0.52.
That's what I got.
What'd you get, Matt?
0.52. So because do you understand what we're trying to find?
Yeah.
I guess I'm having a hard time following. So I know that we're supposed to be finding the...
Yeah, we already have the information because we've already done all the probabilities to figure out, what lies in what area for 0.6 and 0.7. We know that anything less than 0.7, so turned out to be 0.716, so 71.6% chance of something falling below 0.7 grams of protein per kilogram per day.
Yes.
So we also know that for 0.6 grams of protein per kilogram per day to fall below that, there's a 0.196 or 19.6% chance.
So we add those together?
So what you do is you take the 0.716, so anything less than that, because that's our high end, and then the low end is going to stop at 0.6. Now we know anything below 0.6 is 0.196. Okay, so you take that high end, 0.716, and subtract that little bit that's going to be cut off, the 0.196.
Okay, so that makes sense. Okay, thank you.
You're welcome. And so the answer is 0.52. Okay. Does that make sense?
Yep.
Yep.
Same thing.
Do we roll our dice? Ha ha ha, punny. All right.
Yay.
Yeah, we rocked that.
I know.
Awesome. Awesomeness.
Well, and I'm glad we got it all done in one day.
Good job, guys.
Me too. You guys had like record time.
Goodness. We're getting better. So I'm going to go ahead and post this broadcast, and I will see you guys on Tuesday.
Okay, see you guys
Thanks
on
for the hard work, guys.
Tuesday. Yeah, way to go.
Point today.
Yeah.
We
Bye,
had
guys.
a good time.
Bye.
Have a good night.